Graphing of inverse functions. So here we're going to graph our function and our inverse function here. So here our function y is equal to x minus 3 here. So we can use our values here, 0, 1, 2, 3, 0 minus 3 minus 3. So here we end up, here is our straight line, y is equal to x minus 3. And its inverse, the inverse of subtracting 3 is adding 3 here. So we know we've got our inverse right here, and what we have, we substitute our values in, and here is our line y equals x plus 3. And so what we notice is that these are very similar. In fact, they're parallel lines, and they're actually a reflection of each other through this line here. So this line that I'm marking on here is the line y equals x. So this is a very important property for us to notice. So we find that on a number plane, the inverse relation can be represented by reflecting the original function about the line y is equal to x. So here we have a function y is equal to x squared. And so our inverse, x is equal to y squared here. And we can reflect this line here. So here is our line, y is equal to x here. And they're reflected about this line. So we notice that this is not a function. So remember we had our vertical line test here to see if it was a function. So our first curve here is a function. However, our second curve we are cutting twice, so not a function here. And we can actually rearrange this if we want to put it. So here y squared is equal to x, y is equal to square root of x here. So when we look at the difference between the two graphs we've looked at, the first graph, each x value has a unique y value. So from here in our domain to a unique value here in our range, here to a unique value here in our range. For the second graph, there are two possible y values for each x value. So instead of going to one value, we're going to two values here. So to have an inverse function, it must be one-to-one or injective, where each x value has a unique y value. And we can test for this using the horizontal line test. So we used our vertical line to test if a function, or to test if an equation was a function. And now to find out if our inverse of the function is a function, we use here our horizontal line test. So for this test we draw a horizontal line on the graph. If a horizontal line can be placed to cut through the curve more than once, then the inverse is not a function. If the horizontal line can only cut the curve in one place, then the inverse will be a function. So here we want to find out, do the functions below have inverse functions? So we can try a few different points here. 1, 2, here, even right through our x. We're only going to actually cut through our line one time. So yes, we do have an inverse function. Same with our next case here. We cut through, we're only cutting through one time. So yes, we have an inverse function. Here for our next equations here, our next lines, we cut through one time. And now we know this curve here. So this is our sine curve. If we cut through here, we see, okay, we've cut it twice. So here it's not a function, is it? So looking at these examples, we can see our functions that have inverse functions do not curve up and down. They either always increase or always decrease. When an inverse function exists, the domain of the inverse function is the range of the original function, and the range of the inverse function is the domain of the original function.